So it's not the first time that we have a relationship with Enbridge for the Savings by Design. It's enabled us to be an Energy Star builder, and we've been with them since about 2013. My name is Pat Daniels, and I'm the construction manager at Tartan Homes. Tartan Homes is a tract builder here in Ottawa that we build about 200 homes a year.
The motivation for being involved in a process like this is to work directly with builders who are trying to work with changes to building code. By building a home according to the Savings by Design parameters, you're actually building beyond what building code is. So you're actually contributing to a better future, a better climate outlook going forward.
Tartan has always been at the forefront. They were the first Energy Star builder. So knowing that the conditions of our province, wanting to head towards net zero by 2032, we decided that we wanted to be ahead of the curve and be able to understand what we need to do to achieve that. So Mark Rosen was the big part about telling us what we needed to do and give us the options.
One of the things that's nice about the Savings by Design program is it often gets me as an energy advisor involved at an earlier stage with a builder, at a point where they're still considering a specification, kind of outside of the regular parameters of scheduling and budget that are driving those. It allows us to slow down for a minute and have a conversation earlier on before a lot of the big decisions are made. And that can have a long-running impact on how homes get built out and what specs they get built to. What's been really nice this time around is that the Savings by Design program has allowed Tartan to explore a new building standard and had some support in doing that kind of exploration to see what's possible rather than just taking an incremental step forward.
Innovation is a key. Innovation in the energy business is a key. So when we work with somebody like Tartan Homes who brings a new method to the construction market, we look forward to bringing the expertise to them to help them to get to that.
This project is 2 homes. Each home is targeting the net zero standard as defined by the Canadian Home Builders Association. The 2 homes are being built with slightly different methods. One home is being built using a more traditional wood framing approach with exterior insulation and a number of mechanical upgrades. The second home is being built using an insulated panel system that is being assembled as kind of an off-site fabricated kit. Together, the homes are both targeting very tight air tightness targets and are using very efficient hot water tanks, very efficient heating systems, ventilation systems to try and reduce their energy demands. And finally, both homes will get solar panels on the roof to generate the necessary power to offset the consumption that the home itself will have.
Everything starts with conservation. Conservation is the key to a better future. In using energy as wisely as possible, getting the most out of the energy that you're using, any energy. That makes us excited to work with somebody like Tartan Homes, who's also sees the idea of innovating the way they construct a building that will add to the comfort of the home, that will add to the efficiency of the home, that will make for a better product for them in the marketplace, and end up being a better product for the people that buy their homes as well.
So in the hopes of being able to produce these houses in our standard lineup and be able to introduce them as part of what we do every day, we wanted to know if we can do these houses standard, if we can build this as part of our usual everyday tract building component of our business. So we needed to do a house that was typical to what we do. So with the Kawartha, to achieve the net zero status, we went ahead and built it as a standard model using conventional framing components and wanted to bring the building envelope to a 0.6 interchanges.
The biggest challenge that exists now is scale. How do we build net zero on a larger scale? How do we do it affordably? How do we do it within the constraints of a production environment so that homes can be affordable and attainable for the average home buyer in today's climate?
It takes time, it takes education, it takes practice to be able to get to achieve what you need to. We've put ourselves with a higher level so that way we can get better every time we move forward.
What we do as energy advisors to help builders is we do a couple of different types of tests. One of the tests that is mandatory for Energy Star for new homes and for net zero labeling is called a blower door test. And in a blower door test, we take a big fan, we install it in the front door of the house, and we depressurize the house by sucking air out of the house with this fan. We then use a device called a manometer to measure the pressure inside and outside of the house and determine how much air is leaking into the house at a given pressure. What makes this first test unique is that we're also going to use a smoke machine to help us visually detect leaks in the air barrier. We plan to use it to fill the house with a dense white smoke and then turn the fan in reverse and pressurize the house and have that smoke leak out of the house wherever there's a gap in the air barrier. The idea is that we'll be able to see this standing outside the house, and it'll be a really interesting learning experience for everyone there. We're back again today to do the smoke test. So the house is all set and the fog machine's inside. It's all warmed up and ready to get turned on. So I'm going to go inside and fire up the smoke test now. We're seeing smoke starting to trickle out a little bit and we haven't even fired up the fan. So it's interesting that it's kind of naturally finding its way out of some of the openings.
You can see that there's a little bit of smoke coming out here. And these are areas where we've insulated and thought that we've covered pretty well, and now we're seeing, just without the pressurized, that it's already leaking. So it's given us an idea of where our weak links are already.
At the windows here, we're not counting on the tape to be the air barrier, we're counting on the foam that holds the window in place. And it's possible the smoke we're seeing is because the foam is discontinuous or interrupted by shims that are not foamed over on the outside. So when we get the fan fired up, I'm curious how much the smoke will be exaggerated in these spots. See what we see.
So I'm going to get the fan turned on. If you see smoke coming out of the house, make sure you tell somebody wearing a hard hat so they can go and fix it. A lot of smoke coming out, more than I would think for a test that 1.5 air changes per hour. To start, I thought we'd see less smoke, but that pressure was really exaggerating it. So now we're starting to see it come out a few places we weren't seeing before, more up high as well. It's interesting.
Look at the windows. Our windows are really a weak point.
It really seems to be.
I'm surprised. I expected some leakage out of the windows, but not to this extent. I'm really happy with the way the test is going because we're actually seeing a lot of interesting areas, a lot of details that we thought we covered. And to me, it's a success for sure, 100%.
Yeah, it looks like the house is on fire.
Yeah.
It's telling, I think, that 1.5 air changes per hour was our initial test, which is a great number. Still shows this much smoke when you do a leakage like this. Makes you realize that a lot of small holes contribute to that number in order for it to be 1.5 in the first place.
The next step is to seal these holes as much as we possibly can, run it again, or possibly run a blower door test to see how well we did, and try to bring these numbers down to where we're trying to achieve.
So in contrast to the Kawartha home, the Empress is taking a whole different approach to the way a home is put together. As a model, it's a slightly smaller and narrower home. The main difference is that it's being constructed using an off-site fabricated panelized system, as opposed to the Kawartha, which is a site-built stick frame house. The panels themselves are a composite of foam insulation matched with a steel exoskeleton. And once they arrive on site, the idea is that the house can go together quite quickly. All the pieces are already cut to size, labeled, and there's kind of a key plan. It's kind of like a jigsaw puzzle with instructions on how to do it properly.
Here we are at the second home that we are doing in net zero. First one was a conventional stick frame build. This one here we went with a panelized system. And here we are that we've installed our first greenstone panel system here in Ottawa. The challenges were really just to try to understand the product and see how it lays out on the site. And because we don't do any of these, this was our first one. So it kind of had its own challenges of being the first one that we do here at Tartan. Let's go have a look inside. It's panelized system, so it's something that we don't normally do, and that was exciting in the sense that when you bring these innovations forward, you want to try to have different ways of doing it and being able to make your everyday practice as a track builder to make it better, make it faster, make it more efficient. Again, starting a project like this, you'd have to have all the information up front to the site right away because these products are different. You need to have everything up front before you start something like this. Some of the big challenges is actually getting the electrical and the plumbing into these units because these are cut with hot knives to be able to fit it through the foam to make it so that we don't have to lose more space by framing it out or by doing any strapping. The product itself is a great product. I think it could be a game changer in our industry, but again, there needs to be some education to it. And I mean, once we do the blower door test on it, I think we're going to be even more excited with it if we get the results that they're telling us we can get. So yeah, overall, I'm pretty happy with it.
The team is generally very optimistic that the Empress is going to be a substantially tighter home right off the bat. The thought is that this panelized approach to building the Empress lends itself to air tightness much more easily. I'm not so sure I share everyone's pure optimism. I'm hopeful that we see a very good result, but we have no data to compare between the two homes, and I'm really getting anxious to start to have access to some of that data.
I've worked in air tightness for over 10 years now, consulting on houses and trying to help other people figure out how to build airtight houses. So when it came time to build my own, I kind of had to walk the walk. I've been talking the talk for a while, and it was time to prove that I knew what I was doing when I was talking about air tightness. There's a lot of things about how airtight we made the house that I just enjoy every day. Being close to windows, not feeling drafts. It's really hard to overstate how nice that is. We were quite successful. I mean, the house hit 0.47 air changes per hour in its final blower door test, which I'm very proud of. And we did that all through detailing and good labor. I really believe in how important airtightness is, but also how achievable airtightness is. I think it's something that we can do in all houses. There's no reason not to build more airtight houses in every house that gets built. Using other products, using other techniques, it's all working towards the same end goal.
The testing itself was very surprising in the sense that we knew we were going to get some smoke out. We knew we had some weak areas, and we figured that we were going to have some work to do, but where it came from and how it came about was the surprising part. If anything, by showing this to everybody, it basically brings to light checking out all the little details or making sure that you look at those minute details could be a huge difference between having a good air barrier and not having a good air barrier. So here we are. So some of the areas that we found that were problematic was especially the areas where there's beams that were protruding into the unit. And these areas here, we've made sure we sealed it properly, spray foamed them again. Another area that we discovered that was a weak point was steel columns. We ended up foaming the whole column, and we also sealed it at the top so that there is no infiltration of air or exfiltration of air to the outside. All the windows, a lot of them had just a minimal of about an inch into the window of spray foam. They have all been removed and re-spray foamed again. So for future reference, what we've decided to do is extend the RSOs by ½ inch to allow the nozzle to go all the way around properly to get a good foam seal between from the back to the front of the window. It was a great learning experience for everybody involved. It was an amazing experience for the trades as well to be able to see some of their work, how it portrays and how they always thought that what they were doing was the right way, and little detail here, little detail there, and it actually showed itself off really well. Now that we've gone forward and made all the changes and fixed all the issues that we perceived that we've had, we're really excited about the future and what we're going to do with the aero bearer, where it's going to bring us as far as a number. The hopes is that maybe I'll be optimistic again and spend maybe 10 minutes doing the aero barrier if all the repairs we did initially work out. One of the challenges is that as building codes get more and more strict, they put more
onus on the builder to perform at higher and higher levels, and those levels come at a higher and higher cost generally. What we're trying to do with Savings by Design, help builders to find the next level, to move to the next level of energy efficiency, comfort, and performance, but not do it at a level where it just impacts the cost of the house and pushes it so high that homeowners cannot afford to buy the house.
So we're doing kind of a second pretest today. We give us a measure of how much more tightening has occurred just through the course of continuing to work on the house. Kind of don't know. I think we're going to end up somewhere very good. I know that. I just don't know exactly how far along we are before the aero barrier installation. I feel cautiously optimistic, I would say. All right, drum roll please. The air test results, 0.97. Under one.
Under one.
Well done.
Awesome.
Well done.
One of the selling features of this product on the Empress was that we were going to get a much better air exchange for the house, like right off the bat, by having this product, the Greenstone product, being so much more airtight. We thought that going this route would do it without having to go through different mechanical or different products and just achieve it just strictly with the manufactured product. So having not done that yet and done the air test, we're not sure of where it stands, but the results that we're looking for is under 0.6 right off the bat.
So we are doing our first air test on the Empress today. This is exciting. We've been kind of waiting for this one for a while now, so I'm looking forward to it.
Feeling good. I'm excited. It's been a long trek to get to this point. A lot of things have had to happen to get this house where it is, and so we're looking forward to seeing the results of it and seeing all the hard work everybody put in, and hopefully we get the results we were looking for.
I've tested a lot of houses that have gone for 0.6, and 0.6 is a really tough number to hit. If we hit 0.6 today, then I guess I'm buying beer for everyone after this. At the end of the day, when you're putting a house together, the advantages of one system alone aren't always enough to bring you to that level. It has to play nicely with everything else that comes before it, the foundation that was built underneath it, the interface between the two, the roof that goes on top, the trades and their impacts as they come in and out of it. And we haven't had a chance yet to really measure that first bar and see if it's been substantially better or whether we're starting at roughly the same place. Well, this is surprising, but not in the way we were hoping for. The result is 1.97.
What? Really?
Yeah. What we're noticing, I mean, the problems are in similar locations, right? The transition
Windows,
details,
yeah.
they're not the walls, which wasn't it wasn't the walls that were the problem over there either, right?
No, it was the
window
windows.
openings, doors, bump outs. I haven't walked around upstairs yet. I'm just using a smoke pencil now to try and find drafts that are a little bit harder to find than using your hand. The smoke is just disappearing, it's just being blown away. There's a lot of air moving there. Yeah, you don't feel it here. I think we've identified the big one.
That would be pretty big.
I feel some here.
It's all spray.
Right here. Surprised. I thought that we would be lower. What it shows is that whenever you try something new, you have to test. It's not enough to take the guarantees of the manufacturer or, just feel like you've done a good job. You have to test to know. And then you find problems where you didn't know to look for problems. The problem here that we're discovering today is not that the panel system is leaky, but it's the new details that using a different system introduces that we have to figure out for the first time.
When we work with somebody like Tartan Homes who brings a new method to how tests failures, more tests, more failures, and then hitting success, it's very exciting for us to watch that process evolve and know that the client at the end is driving exactly where we hope they will and that we're a part of enabling that process.
Sometimes the leaks, as the houses get tighter, are more difficult to detect, and then we have to go to more advanced tests to try and find out what's going on. AeroBarrier is an aerosol-applied air barrier system. Basically, the home is pressurized using the same type of fan that we use for a blower door test. And while the home is being pressurized, an aerosol is sprayed into the air using a series of nozzles that are positioned throughout the house. The aerosol itself is made up of a compound that, when it accelerates through a small opening, congeals around the edge of the opening and starts to close the gaps. And it can seal holes anything from 5/8 of an inch down to nothing.
This is the first time that we're using AeroBarrier, so very excited to see what the numbers are going to come out as. When we started with the savings by design, we were hoping to achieve a home that had a comfort level, an air filtration level, that we had set up some goals, and with this AeroBarrier product we were really pleased that we achieved all those goals. We were looking for a goal of 0.6 and we ended up with a 0.41. So for us it was fantastic results and we're really excited about it. So what's next for us is we're going to give ourselves an internal goal of 1.5 for our homes now, because we were able to find all these details and be able to really drill down on our air infiltration. And we're extremely excited about moving forward, and what we hope to achieve is better homes, better quality homes for the future, and using savings by design as part of that.